The last thing that we'll do in this section is what we've actually already done before. I want to show this picture to you. This is your entire unit circle. We've been working up to this the entire time. Whether you believe me or not, you have actually done everything on this unit circle so far. I will not make you memorize this. In fact, you don't need to memorize this. If you know your special triangles from before, so if you know your 45, 90 triangles as 1, 1, square root of 2, and your 30, 60 triangles as 1, square root of 3, and 2, you know this entire unit circle. Okay, so we're going to do an example or two over here. We'll do one that deals with degrees and one that deals with radians. So for letter A, we want to find the exact value of cosine of 480. Our unit circle only goes between 0 and 360 degrees. So let's take 480 minus 360 to see where we're located. And when we do that, we're going to get 120 degrees. So if we find the value at 120 degrees, we'll have the same location as 480 degrees. On our coordinate plane, let's plot where 120 is located. That would be in the second quadrant. Remember, from there to there, that would be 120 degrees. We always draw in our right triangle with the x-axis. Find our reference angle, which is located right here. And that would be 180 minus 120, which will get us 60 degrees. And then we can use our special right triangles that we had on the previous slide. Across from 60 is our square root of 3. Across from our 30 is 1, but we got to be careful. We're at a negative 1 because we went left of the origin. And then our hypotenuse is 2. Cosine of 480. Remember, cosine is adjacent over hypotenuse, so adjacent with our reference angle is negative 1. Our hypotenuse is 2, so the answer is negative 1/2. We can do the same thing even if we're given radians. In fact, if you are given radians, I would just convert it right away to degrees, because that's what we're used to, and that's how we get our reference triangles anyway, is with degrees. So I'm going to state, in order to do this, instead of 11 pi over 4, we're going to change it to degrees by multiplying by 180 over pi. That's something that we had already learned about before. Your pi's are going to cancel. So taking 11 divided by 4 times 180 gets us 495 degrees. So if we find sine of 495, that will be the same thing as 11 pi over 4. Again, I don't have any location between, or that shows 495 on my unit circle, so we're going to subtract away 360. 495 minus 360 is the same thing as 135. So let's find sine of 135 degrees. 135 again is located in the second quadrant. There's 135 degrees. You can find your reference triangle. 180 minus 135 is going to get us 45 this time. Draw in our right triangle. Across from this 45 is going to be a positive 1. The bottom is going to be a negative 1, because we went left of the origin again. And then our hypotenuse is square root of 2. Sine is opposite over hypotenuse. So opposite of the 45 is going to be 1. The hypotenuse is going to be square root of 2. So sine of 11 pi over 4 equals 1 over square root of 2. rationalize square root of 2 over square root of 2 gets us an answer of square root of 2 over 2 as our answer.